everyone. This is Dr. Aravind Rajan from the Department of Aeronautical Engineering. I'm an associate professor over there. And in the last class, we were seeing about aircraft systems. So we saw about generic systems and what are the components and how do we design a generic system. And right now, we'll be actually continuing with what are the different types of aircraft systems. And in aircraft systems, we actually have airframe systems that we have already seen in the introduction of this subject. I actually showed you what are the different kind of aircraft systems and their subsystems. So here, as you can notice, there are systems and subsystems which are marked in red and the other one are in violet. So the one in red are nothing but physical systems, which means you can see them physically, you can touch them. And the other two, that means those are marked in violet, are actually non-physical systems or numerical systems. So we can see that an aircraft is actually composed of different systems known as airframe or airborne systems, vehicle systems, avionic systems, and mission systems. So first we'll be dealing with airframe systems. When you see airframe systems, it is nothing but the structural components of an aircraft, where you have wings, empennage, and fuselage. So let us start with the wing. And you can see in a fixed wing aircraft, if you don't have wing, you don't have lift. That is why an aircraft, actually, we have already seen the definition of an aircraft, which is, it is a vehicle which produces lift through air. That means due to aerodynamic lift. There is a pressure difference between the lower and upper surfaces of the wing, which generates actually the lift, which is the vertical component, positive vertical component, which takes it above the ground. So if you don't have fixed wing, you don't have lift. In case of a fixed wing aircraft like civil aircrafts or military aircrafts. I'm not talking about rotary vehicle systems, okay? We are talking about fixed vehicle systems. So, wing is a major component which produces lift. But due to lift, we also have other two forces that are unavoidable, which are nothing but, or unevitable to be precise, drag and nose down pitching moment. When an engineer actually designs a wing or who designs an aircraft system with a wing, his main aim is to increase the lift component L and to decrease the drag and pitching moment components. So as a system it is, aircraft system actually requires different design requirements. These different design requirements are actually related to performance, stability and control, and operational, cost, and also flight safety. Operational and cost are most probably the least affected factors. But the factor that influences the more on an aircraft design, wing design, are nothing but performance, stability, and flight safety. If you can see over here, what I have is a detailed design of wing, where you see which is center wing, which comes under the fuselage, and you have the leading edge slats over here, and you have the trailing edge flaps over here. You also have the control systems such as inboard aileron, overboard flap, and outboard aileron, and wingtips. In wingtips, generally you can have no winglets, and nowadays aircrafts come with winglets. Okay. So when you design actually this, you need to consider different subsystems that are accompanied in the wing. For example, what you see here, you have the propulsion system, which is a vehicle system. And this engine actually must be accommodated in this leading edge. And you have the fuel systems, which actually pump the fuel to your engine. And you also have the control systems known as spoilers, leading edge slat, which produce high lift. And that means they actually increase your camber of the airfoil to produce aerodynamic lift. And in the bottom left corner, what you can see here is a figure of Airbus A340-500, which is one of the recent and most used long-range aircrafts, 4-engine aircrafts. And the one which are shaded in blacks are actually the fuel tanks. So you can see that the wing actually houses 6 to 7 different fuel tanks. The main fuel tank is in the center, which is for balance, and the other 2 fuel tanks where you have each on 3 fuel tanks on each wing. Other than this, you also have aft tanks, which are behind the fuselage bulkhead and in the empennage section. So when you are designing an aircraft system which is related to wing, you should actually consider all these things. So it is actually a system which houses different subsystems. For example, if you go back to the flowchart here, you have the airframe structural system and you have the vehicle system, which are physical systems. So in the airframe system, we have a subsystem which is wing, whereas the wing actually houses propulsion system, fuel system, flight control system, and also hydraulics for the landing gear. So what other subsystems which are related to vehicle systems actually find their way into wing, which is a subsystem of airframe systems. This is nothing but an integrated subsystem. And when you see further, you have the second, which is known as the empennage. Empennage is nothing but the tail part, which the empennage is the part of an aircraft which finds itself behind the aft bulkhead. Aft bulkhead, that means after the cabin, where you have the horizontal and vertical stabilizers. As you can see, this is the vertical stabilizer, and this one is actually the horizontal stabilizer, H. And when you see here, you have the control systems which are nothing but elevator. You have the elevator and you have the rudder. So elevator and rudder are the main control systems which control the stability and trim of an aircraft. Or else, in speaking in other words, an elevator is the one which actually produces pitch up and pitch down movement. And rudder, it is for lateral control system, which gives you yaw movement. And ailerons, which find themselves on the wing, actually produce roll movement. But the most important control system that is used in the empennage is elevator. Rudder is actually a secondary control system. I might say secondary because it is not literally secondary, because rudder has its own important use when you have loss of engine or loss of thrust. For example, you take an aircraft with two engines. When you Boeing 737 MAX 800 or Airbus A320. When you do so, if you are losing power from one engine, to control the aircraft, pilot actually uses the rudder. That is the reason why rudder is actually used for latitudinal trim. And these these parts of an airframe structure, that means the empennage, from this topic, what you can say is the empennage is actually its main principal component or principal work is for stability and trim. It doesn't produce lift. Lift produced by these two, most probably the horizontal stabilizer, is literally zero. Okay, but when you design these two components, such as the vertical stabilizer and the horizontal stabilizer, the parameters that we use are almost similar to that of a wing. For example, we have airfoil, NACA, airfoil, and you have aspect ratio AR. You will be having the sweep angle lambda, and you will be having the taper ratio gamma. So all of these, which you will be using, which are the same parameters that you will be using for the main wing. But there is another thing that it is generally placed in the aft section, that is in the empennage section, is the alternate power unit, APU generator. In case of thrust loss, the pilot generally uses APU to restart the engines for producing main thrust. Okay, so empennage and these airframe systems are actually not seen in detail in this course, because they are heavily interconnected to airframe structural design. So when you are studying airframe structural design course, you will be actually seeing in-depth analysis of each and every single component of this empennage or wing or even fuselage. Speaking of fuselage, the next part of the airframe systems is fuselage. So fuselage is where we have our pilot component, cockpit. We have our cabin in the sense where you have passengers or payloads. But in general, for a civil aircraft, you have both passengers and payload. Payload in the sense cargo capacities. For example, here you can see on the top left corner, you can see the different parts of an fuselage of an aircraft. And when you see below here, you will be having the different forces that will be acting on a fuselage during the course of the flight. And when you're designing a fuselage, for example, if you're designing a civil aircraft, when I say passenger aircraft, you should actually take care of all these cutouts that you will be using for passengers' ergonomy. And you also, it is common there to use the doors and the bulkhead ease capacities to use in all aircrafts where you have inlet and outlet of passengers or pilots. But when you see the cargo aircrafts, you will be having the cargo control doors over here, which is front and aft cargo control doors. For example, if you see on the top right corner, you actually have different bulkheads. So abreast is nothing but number of seats that we will be finding in a cabin. 6 abreast means you have 3 and 3 with a single aisle. And more you increase the range, more you need abreast. Or this can also be used for example, if you are in economy class, you find more seats, sometimes 10 abreast seats. And if you're in business class, you'll find 6 abreast seats. And if you're in first class or other luxury classes, you'll be finding only 3 or 2 or 4, if possible. Yeah, 4 seats. So the interior design is a different part. But what you see here is actually a bulkhead which you will be using commonly. For example, if you are taking an Indigo flight from Hyderabad, bound from Hyderabad to New Delhi, for example, most probably you will be boarding an Airbus A320 or Airbus A300 series. So when you see that, you have one bulkhead. Sorry, not one bulkhead. I mean, you have the cargo capacity which is below, and here you have the passenger compartment where you have 2 aisles. That means it is normally a 6 abreast seat capacities. And when you design a fuselage, you must actually consider reinforcing it using bulkheads, which are nothing but these sections are known as bulkheads, and you will be having longitudinal lines or not lines. They are actually rib sections, which is known as longerons. Longerons which go from each part to the other part. But when you are talking about a fuselage, you actually have the environmental control system, the avionic system, the hydraulic system, which operates each and every door in the cargo compartment, and you also have flight control systems which run all through the length of the fuselage. For example, pilot is sitting here. Pilot, he controls something. This, for example, a pitch up movement. He has to send a signal from here, which runs through the avionic control bay and gives a signal to the actuator over here. So the fuselage is the one which houses everything. So fuselage is one of the most important components of an aircraft, where you have each and every subsystem. Even though it is a subsystem of an airframe system, it actually houses the components which will be used in avionic systems, pneumatic, environmental control, safety, and other subsystems. So right now we have seen airframe systems. Airframe systems are nothing but physical systems which consist of wing subsystem, empennage subsystem, and fuselage subsystem. Do you get me? So these subsystems are actually physical subsystems. I have not gotten into details of each and every component of this airframe subsystem because it is not the objective of this content. Because it is actually studied in airframe structural design, which is a course apart by itself, and you will be studying in depth, and you will be doing stress analysis and even drag analysis of each and every system when you are doing airframe structural design and also flight vehicle design concepts. So right now we have finished airframe subsystems, and in the next class we will be seeing the second part of an aircraft system, which is vehicle systems, which consists of pneumatic subsystems, flight control systems, and also flight control systems, propulsion, and hydraulics. So these are the components that we will be seeing in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.